The next generation in mobile technology is defined in a standard known as 5G. It is expected to provide internet connections at least 40 times faster and with at least 4 times more coverage worldwide than the current standard, which is known as 4G LTE or 4G Lite. It's all due to a massive FCC spectrum release, plus new advances in wireless technologies. This new technology is called millimeter wave radio spectrum. And you have to look at it as a new technology that is obviously paired with the fact that the FCC, in its infinite wisdom, has decided to release tons and tons of additional spectrum, normally spectrum that would have been released for other commercial, maybe even military uses. What that means is that we're going to have a mobile technology that is going to work almost 100% faster than all the mobile technology we're all using, the people around me right now. It's a complicated technology, and I want to walk you through it in the following series of graphics. Higher frequencies carry significantly more data, and they are also far more easily blocked by stuff like buildings, foliage, and sometimes even rain. So the problem has been that their use for mobile communications has become quite challenging. Some existing systems actually use these frequencies for fixed point-to-point wireless connections, but they have to have clear lines of sight. But what's been happening is kind of rather marvelous. There have been some advances in signal processing, some advances in chips, and some actually very, very cool antenna technologies being developed by companies like Samsung, AT&T, Verizon, Ericsson, and a bunch of others. So they've been able to use this spectrum to develop next-generation mobile connectivity. I previously mentioned NYU, and those and other demonstrations across the country have shown how what's called millimeter wave signals can be used for mobile communications, and they get around the biggest problems, which is being blocked by objects that come between the transmitter and the receiver. It's quite complex, but let me simplify it for you if I can. What we have here are arrays of tiny antennas on chips or on miniature circuit boards, and they can literally steer a signal in specific directions and mitigate this downside. And in this world that we live in, this is known as phased array. And to give you an example, I recently saw a demonstration by Samsung, and they have prototyped a 32 antenna phased array in a handheld wireless device. Yes, and Samsung, Ericsson, and Nokia all have equipment that are preparing for similar trials. You can't come to the Mobile World Congress without spending a fair amount of time on the internal parts of a mobile phone system. The wiring, the chipsets, the infrastructure, the antennas. This year I had the opportunity, based on an invitation from Nokia, to learn a lot more about the infrastructure, the actual workings of a phone and the entire mobile ecosystem. The Nokia sessions obviously were very, very detailed, very, very thorough. The people presenting them were incredibly talented. Let's start right from here on 4G and 5G and then walk us through the steps.
Okay, I will do. So we're standing here and we are all on the path to 5G. So we want to show you where we are with 4G in the moment, and we give you a quick example how we can download 2 gigabits per second with actual current technology. So Ashish, please press the button. Let's see how fast. So you see in 0.4 seconds we have downloaded 2 gigabit with current technologies. This is still 4G technology, and we call it 4.5, and we will go with until 4.9G, so nearly 5G, up to 3 gigabit in the next month. But then 5G will start. But what will happen with 5G? What we currently see here is we have aggregation of carriers. We have massive Mimo, and what is massive Mimo? Let me explain it. You might see an antenna. An antenna can transfer a signal, but let's assume between the antenna and the recipient, there is a pole or something like this. So there's a white spot behind. Massive Mimo is different. Instead of having one big transceiver, you have many small ones which can then go around the pole to the recipient. So it's much more flexible and much more capacity possible to get it to the device.
And that's what these antennas are?
Yeah, for example, let me show you on the top. You see a 360-degree massive Mimo antenna, so it goes around the pole even to go in all directions. So that means we will get all the signals across the streets without any white spots anymore. And we have much more boxes, much more antennas, remote radio hacks, smaller ones, bigger ones. So 5G ready platform and the 5G antennas already included. Of course, you have to transport from the access to the core all the traffic. How do you do this? For that, you have, we call it front haul, back haul, or simply any haul, any technology. It can be the classical microwave, which transmits signal. It can be optical, IP, etc. And all these technologies are controlled by software. And this is called then the software-defined network, SDN, across all technologies. When you look down, where are we walking? We are walking on a street. And you know the traffic problems on the street when you don't have a dedicated lane for you. And this is same as in the actual LTE network. Now a really dedicated lane for you. With 5G, we have a feature which is called network slicing, where you can get your dedicated lane with your dedicated latency or capacity, whatever is needed.
So this is why, for instance, in this particular case, BMW, which you're partnering with, or actually a customer of yours, this is why BMW, they want their own lane. They want their own slice.
Correct.
They don't want to mess around with your slice or his slice or emergency slice. They want a BMW slice.
Yes.
Okay.
And 5G is then able to have thousands of slices in the network for whatever is possible. And you can also think of an emergency scenario. That's what we're showing here in the city. And the explicit example will be an accident. So we don't see it right now, but an accident will happen. And then in a second, the city has to create automatically a slice for the, let's say, data connection, for example. That all the important firemen have a free signal.
So there's in effect an emergency slice, a BMW slice, my particular slice, my Facebook slice, whatever.
Correct.
And that's one of the magical things, wrong word, but that's one of the things that 5G brings to us that we have not been able to have before.
Absolutely correct. And plus, and that's also important, you can do it automatically in a very short time frame. Take it like this. For example, emergency has to be done within a minute or 30 seconds to create the slice. So automation is key also here for the slice creation. And then we come, let's say, to the last important point. And that's the machine learning aspect of radio. What we see currently in Nokia is we're using a lot of hardware, a lot of equipment. It's getting smaller and smaller. What we have done and released last week is our ReefShark chipset, so our own chipset to put even more things into the chip. And we all know it from the PCs, they get more and more capacity, but getting smaller and smaller. Same here, our radio stations will still have an antenna at the end, but the functionalities are integrated in chips, or they will be put into the cloud. Cloud RAN, cloud radio access is one key point here. So less equipment, more functionality in the cloud, and because you can transmit with low latency all the functionalities directly from the next data center to the base station. Plus, we put intelligence into the chips. Why do you need intelligence or base stations? Because today it can happen. We are standing close together right now, and if I call you, this call is not going from my phone to your phone.
My problem is, I was going to say voice, it's going to go bing, 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 it's going to go through a million channels.
Whatever.
And come back to me, whatever.
Yeah, and the same in the base station and the access network. But if they are intelligent, they can see, hey, you are my next one. Let's get the traffic right now to you, or you have free capacity. Let's bring it over to you.
But is this also one of the things we talked about off camera? This is one of the reasons Nokia is building its own chips?
Correct.
Because you guys know what you want. Why buy from Intel? Because
of course, we are working with Intel.
No.
But now we have a better capability to put our intelligence into the
That's what my point was.
Yeah,
that's an interesting move.
In a nutshell, and this is a bit of a buzzword, but I'll slow it down as I say it, what we're creating are application-aware mobile networks, so that the mobile network actually knows what application you're using and gives you the appropriate amount of bandwidth, connectivity, delay, appropriate to what you're doing. If you're doing a conference call or you're watching video, or let's say you're a public safety operative, all have different needs and they need different things from the mobile network. So we're creating different lanes on the mobile network. That's why we call ourselves Cloud Street. That's the analogy. Sometimes you're on a bus. It doesn't matter how fast you get to work. Sometimes you really need to get there if you're an ambulance. That's the difference, but on a network.
This demo is also highlighting something else, which is called edge cloud. So practically, edge cloud means that the recorded videos are not going out from the edge cloud storage as such for the users that are here in the stadium. So even less latency will be there. So those are who are in the stadium and enjoying, or want to see some different angles of the game. The latency when the certain other views are arriving to the tablets will be even less. Mobile edge cloud is a technology where certain applications are moving to the edge of the cloud. That's why we call it edge cloud. In this very application, the edge cloud consists of video servers that are actually temporarily storing videos in the cloud, at the edge of the cloud, so close to the antenna, and then it immediately can turn back to the end user devices.
I hope you enjoyed the video, and if you're wondering where I am right now, I'm in Rome. And this is the old ancient Senate of Rome. And down here are the ruins of the rooms where Julius Caesar was stabbed. Just a little historical note for you. And if you want to subscribe to all my other videos, just click right over here.